All right, welcome back, students. We are going to get into a new topic, which is that of conditionals. These are sometimes called branching statements. So we're going to kind of think of this as if, else, and whatnot. So some quick terminologies just to review here are that of statements or single line statements, which is just a single line of code that ends with a semicolon. We've seen lots of this, that semicolon has pretty much taken the place of a period for our punctuation mark here. The other type of punctuation is the block statement. And this is when you have several lines of code contained within curly brackets. Right, we've seen a little bit of this when we looked at our continuous input example and also with our parsing an int example, where we had, like, for example, with the continuous input, we had a while loop, and we had to have everything within inside the curly brackets of the while loop for the program to work correctly. All right, the first thing to talk about is conditional if. Conditionals are used to test whether certain conditions are met. This is typically done using if else. Think as this of as if this is true, then do this, else do this other thing. Very important here, all right? And this is something that we probably have already encountered as an error when you might have been making the if else statements for the parsing an int, is you do not put a semicolon at the end of a statement. This will lead to either just syntax errors or could even lead to logic errors. Right? Therefore, it's best practice to use block statements with curly brackets in order to contain our code. We don't want to get in the habit of using semicolons, because a lot of you may have noticed that caused some issues. And like, why do I have this error in my program? And it's because you put a semicolon there instead of curly brackets, or you had curly brackets and you added a semicolon. So that's the reasoning. So here's a quick sample code. If x is less than 5, counts to the right line, the value is less than 5. Else, counts to the right line, the value is 5 or greater. Very simple logic here. X is less than 5. This, if you're having trouble conceptualizing this, think back to math when you had to deal with number lines, for example. And here's 5. Right? And in math, we had like a less than symbol. Right? So we had left a hollow circle. So if x was less than 5, it's all the values below this line here. I can even change the color if you want to really help emphasize that. But if you notice, it doesn't include 5, and it doesn't include anything above 5. Okay? So that's exactly what it's saying. So anything that's smaller than 5 goes here. Now, we don't simply have to put just right line statements. We could have it do other things inside of that. So, for example, if x is less than 5, I could have it say, like, add 1 to x, or I could add 10 to x, or multiply x. I can do whatever I want with inside these two curly brackets. Same thing here. If it's not less than 5, I could have it do whatever I want inside of here. Now, the important thing to note with else blocks are not always needed. Believe it or not, you can get away without having an else block. Sometimes we don't need the else conditional because sometimes we're only really going to need to check for if. We don't care about the other conditions, even though it's like else is like our catch-all. Pretty much if it doesn't meet this, everything else goes in else. All right. That's the nice thing about else. It acts as a catch-all. All right. Now, an important thing to know is that, well, you may not need else. You always, when you're writing conditionals, going to need an if. So you can't just put else because the program will like, well, where's my if statement? You have to have if first, and then you can have an else. All right, here's a quick sample code that shows in this case I don't need an else. So here I have if x is greater than 5, x is equal to x plus 2. And you notice in this case, it just checks to see if x is greater than 5. It doesn't care about when x is less than or equal to 5. It only cares about when x is greater than 5. All right, next let's discuss multiple ifs. Sometimes we will need to test for multiple conditions. Like you want, certain things that happen at certain points. And while yes, you could write multiple if statements, it's really not the way to go about doing it. All right, when this happens, if we have a multiple if followed by multiple else ifs, and then we typically will conclude with an else because else again acts as our catch-all. Else if is written with similar syntax to that of if, so we have the parentheses there with some kind of condition in it. So if we look at an example here, I have if x equals 5, counts on the right line, x has the value of 5. Else if x equals 10, counts on the right line, x has the value 10. Else, counts that right line, x is a different value. You'll notice again, else x as a catch-all. It doesn't care about what these two values are. It simply just says x is a different value. All right, now those examples are pretty easy to see, but a lot of times we're not testing simply just for one thing. We have to test for multiple things, and that's where we get into using and or. So what happens if we want to test for those multiple conditions at the same time? For example, if I want to test to see if a number is greater than 0, but is less than 100. That's a perfectly reasonable example. Well, if we think back about this algebraically real quick here, let me just back this up here. So in math, when we think about that, well, back to our number line example. In math, when we think about that, so we put 0, and we have 100. All right, in math, if I want to see if a number is greater than 0 but less than 100, that means that this has to be hollow, and this is hollow. So two open circles here. And if it's greater than 0, it has to be all these numbers here, but it has to be less than 100, so it's all these numbers here. So it's this middle shaded region here, if you're thinking about this in terms of math. So in order to do that, we have to use either an AND statement or an OR statement. And AND is represented with a double ampersand, and OR is represented with these two vertical bars. So in our case here, we want to use an AND statement, because if you think about this with algebra, this right here, back in algebra, was an AND. Right, it's a compound statement. So here I have if x is greater than 0 and x is less than 100, counts it up right then, x is between 0 and 100. Okay. So that's exactly what this AND does. Now, of course, you don't necessarily have to just test this with an example like this. You can use other things, such as testing to see a string. See if someone, let's say, if string equals hello or string equals goodbye. You could use and there, or you could use or. You know, it's however, whatever values you want to test, you can put those in there. We're just using simple ones right here because it gives us a quick demonstrational purpose. Now let's look at an or one. Here I have if x is greater than or equal to 0 or x is equal to -5. So if we think about it this way, and I said if x, we know I have is here's my -5, and I have 0. So x has to be greater than or equal to 0. So greater than or equal to, remember that's going to be filled in now, and greater than, or x is equal to 5. Right? So all this set here plus this additional point right here. Right? So this is an OR statement, which means it includes everything. It's not simply just going to be where the two lines overlap, if we think about this in terms of math. This is everything that is in there. So x, it has to either be greater than or equal to 0, or x is equal to -5. If it does, x is either 0 or larger, or is equal to -5. Now, some quick symbols of note here for you as we start looking at these different things. The first thing is the double ampersand, as we already mentioned, means and. The two vertical bars that you see, that means or. Obviously, a left arrow bracket means less than, and a right one is greater than. Now, because we don't have a symbol on our keyboard to represent less than or equal to or greater than equal like we do in math, we have to follow that up with an equal sign. So this symbol right here and this symbol right here, if I give us a blank canvas, so this in programming is represented with this. So less than or equal to and greater than or equal to. Right? So they're the same things, is that because we can't physically type those symbols up on our keyboard, what we do instead is that we simply just put an equal sign after them. Similarly, we have to do a double equal sign when we're comparing two numbers. Because if you recall, a single equal sign means set the value of, like for example, int x equals 2. When I use just a single equal sign, that means set the value. Now, we can also check for when something is not equal to. All right, so for example, I can check to see if x does not equal 2. It's a very quick and easy way to do it. Now, one thing also to note is that typically these two right here, and the reason why they're over here separately, are generally avoided in good programming practices. A lot of times we'll stick with using these other inequalities because this can lead to, when we get into loops, this can lead to some errors. But for our purpose of just starting off here with testing, these are perfectly okay. Now, there's one more thing I'm going to show before we get to our conditionals, and that's what you guys are going to be working on tomorrow, is something that's known as what's called a truth table. So a truth table pretty much is where you have two conditions, and you test to pretty much see if they're true or false. If it's true, you put true. If it's false, it's false. So, for example, I want to see if x is greater than 2. Right? Obviously, x has to be greater than 2 would just give me two things. Now, where this comes in handy is when I start getting into things such as or. And then I check to see if x, let's say, is less than -1. When you start looking at truth tables, right? So when we have our ors, we'll have two conditions. We'll have an A condition and a B condition. And with or, pretty much the big thing about this is that you're always going to have something where you have something to be true. And it's typically not represented like this is actually just poor representation of a truth table. With or truth tables, the thing that you'll typically see is everything is always true except for that one condition that is false. With an and, it's pretty much different. With an and, you're going to have the one condition that is true and everything else is false. All right, and we'll do just a little bit of practice with this tomorrow, just so you can have a little bit more clear understanding of how these two conjunctions work. Now, let me just jump over here to our demo. And I'm just going to really quickly make up some conditionals. So let me just do a quick int. I'm going to do x equals 2 or 3, and let's do y equals 2. And I'm also going to do one with strings. So let's do string input. I'll just call it string test equals quote hello, and let's call it test2 equals quote goodbye. So let's just test the two ints first. So let's say if x is greater than or equal to, let's say 5, we're going to have it say console.writeLine x is greater than or equal to 5. Now, of course, like I said, you can have it do other things in here. So I might, for example, also have it do like console.writeLine x times 5. So I can still do other things besides just have it spit out x is greater than or equal to 5. Now, we can obviously see x is 3. So x is never going to be greater than or equal to 5. So in that case, this would never happen unless I put an else in here. If I put an else in here, then I could say like console.writeLine x is not greater than, or I could even just write x is less than 5. And I could have it do whatever kind of thing I want after that. Now, of course, we can also do else ifs. So, for example, I could say if x, let's do a conjunction this time, if x is greater than 5 or y is less than 5. Now, because I have put an or here, only one of these conditions has to be true. So what I'm going to do is I'm going to go ahead and say in here, council dot writeline one of these conditions are true. Now I can put an else if here, and let's test the and version. X is greater than 5 and y is less than 5. Council dot writeline both of these conditions are true. And I'm not going to end this with an else simply because I don't necessarily have to. Remember, else is optional, so I'm not going to do it this time. But let's just do one more to demonstrate that we can do this with strings as well. So if test dot equals, and let's do hello, and let's do this time a we're actually going to do one other thing, which is we're going to nest here. And so we're going to say if this is equal to hello, I can actually put additionally other ifs inside of ifs. So I'm going to say if test equals hello, then I'm going to test to see if, what's the name of the string, test2? Test2 dot equals, and I think I made that one equal to goodbye. Let's have it say goodbye, but make it spell a little differently. Council dot writeline let's have it say test plus and goodbye. Test2. Okay. And let's just put here in here a else council dot writeline test plus and test2, just to show the difference here. All right, now because these are the same thing, I'm going to change this to or, just so it's a little differently. Now we have quite a few things going on here. So I want to go right after here, and I'm going to put in my council dot readline. So one thing that we're missing here that you'll want to make sure that you add into your own code is your comments. And now when you get to doing your if statements, how you want to do those is just test to see if, for example, like this first one, x is greater than or equal to 5. And that's really all you had to put. If you do something like this, you can just test to see if x da da da. Because you have multiple different things going on here, what you could do is you'll come in here, add a comment here, and you might add a comment here to show how these two are testing different things. All right, let's just run our conditional demo. All right, so I have x is less than 5. One of these conditions is true, hello, or goodbye. So there's my program, folks. And I think that's a pretty good list of how this different stuff works. Again, with the truth table stuff, don't worry too much about this. You'll get some practice with it just to kind of help you understand a little bit about how and or work. And also it'll give you some practice on just testing to see if a value is true or not. and then you'll get some labs after that. So until next time.